Well, hello everybody and welcome back. We're into week 3. This is a quarter way through the semester, the module. So this is the last 2 classes with me for now anyway. And what you'll have then is your networking side will come up next. So we're going to plow ahead and get through some more advanced features that I really think you'll get a good benefit from. I'll just stop my screens there now. Right, so this week, what we're planning on doing is going through your loops, your menus, and most importantly is a feature called SED, S-E-D, which stands for a streamline editor. So very efficient and effective way of using and manipulating files, such as printing particular sections or maybe deleting empty lines or deleting particular sections. Anyway, we'll come to that. I'll get started first on just a recap of last week. So last week we did the loops. Oh, sorry, that's this week's class. Looking up on the screen there. And the lab there as well. So you'll see the first part of this week's lab is your conditions and loops. All familiar to you at this stage from your programming experience, and you've got loop manipulation, so using some of the features inside loops to, I suppose, get away from the defaults. So you can use breaks, you can use continue, you have case and select, and they're being able to create menus for the user to select options from. And then we're into the SED, S-E-D. So your stream editor, which is used primarily, a lot will be used for find and replace. So it's manipulating files that you'll have. And again, of course, you have your lab that I'll keep on linking over and back to, because I'll go through each of the sections and just link you to the lab for that. So last week, if you were having any difficulty, I hope that you've said help on Slack for starters. But if there's any issues, just feel free for starters to use some of the many resources that are there. And again, if you find something that you think is useful, please feel free to share it on Slack. So this is a link, as you can see on my screen, but if you're using it, if you're just looking at this, browsing it from the web-based, you might need to download the file to get there. So it's not, as far as I know on the tutors, it doesn't work as a link, so you just need to download it. Or else you can just do a search, Ryan's tutorial, bash scripting tutorials, and you'll see there's so many great resources available to you. This is one of many. So with your arithmetic last in week 2, we spoke about using the EXPR arithmetic expansion using the $ and the double parenthesis, your double opening and closing brackets around it, is a more efficient way to do arithmetic when you're working in bash shell scripts. So your shell variables, any variable that you're using, as you know, they're treated as strings, not as numbers, which adds a little bit of complexity then to using that EXPR. So your arithmetic expansion, this $ with your double parentheses, your double brackets, they allow for the evaluation of any of these arithmetic expressions, and they'll substitute the result. So the format is as it is on the screen there, your $ with your opening brackets, whatever your expression is in it, whether you're adding, subtracting, multiplying, dividing, whether you are comparing, and I'll go through some of the common characters for those as well. They will all be treated as if they're within double quotes. So you can see here, if you were using this arithmetic expressions, your double parentheses, your double brackets are a more efficient way of doing it. They allow for C style manipulation of variables within bash. So using all of them, you can also use your what's it called? When you, oh my God, I've got a blank. What, increments, God almighty. So you can use increments or decrements when you're using arithmetic expansion as well. So whatever your variable is, if you add the variable name and a plus plus, it will increment it by 1. It's the same as saying plus 1. And similarly, you can decrement it as well. So some of the commands used are a little picky about things like spaces around operators when you're using your EXPR. So within your bash shell, arithmetic, if their arithmetic expression is placed within these opening and closing brackets, it is far more forgiving about spaces, and it makes it much easier for us as the end user to read as well. So you can see some of the advantages on the little blue text box there. So if we had a variable called myvar and we set it to be equal to 100, using the EXPR expression, you would have a dollar sign, you have your curly brackets, and you have your my variable. What about a more efficient way of writing it? Just in here, if you wanted to do, oh sorry, that's covering over some of it there. 1 second, I'll have to change that up. That was meant to be, when you have it multiply, you can see here multiplying it by 3. Okay, so your arithmetic expansion, some of the common characters and formats that you'll use, you can see them here. So you have addition, and there you have your dollar. You can see where the dollar signs are also valid as well. So there's a good list of them there that allows you to add, subtract, multiply, divide, get the exponential, get the modular division, increment it, decrement it, multiply it by a constant, divided by, and so on. Right? So in there you can use any of those. So that's a more efficient way compared to the older EXPR. Okay, so that's from last week. Similarly, from last week we used some pipes. I'm just going to run through a little bit of the science bit behind it. So your pipe is when you're feeding the output from one process, from one, let's say ls minus L, and you pipe it into whatever it might be. So you have the output of that becoming the input to the next process. So when you're working with pipes, it feeds the output from the program on the left of the pipe, or the straight vertical line. On mine it's beside Z on my left hand side. So it feeds the output from whatever command it is on the left hand side as the input to the command on the right hand side. Okay, so if whatever your command is over here on the left hand side, ls minus L for example, that can be piped in here, and maybe you're doing a word count, maybe you're doing a line count to see how many files are in it, maybe you want to check how many directories are in it. You don't actually want to see the output of ls minus L, but instead of it you're using the output of it as the input into another command. So you are not limited to using a single pipe command either, because you can stack them as many times as you want. So you could have the output of the second command being piped into the input of the third command, and so on and so on. Okay, so it takes the output from one command and uses it as the input from another. So they allow you to chain multiple commands at the same time. You can run them consecutively. So you can create more powerful commands then in a much shorter space of time, and make it a far more usable and readable then for the end user as well. Okay, the main purpose here of using pipes, so one of the most popular uses would be when you're using it alongside a command such as sort or such as grep. So obviously you can use any command, but these are very common ones. So they're some of the most popular uses. So you want to find the ls minus L, the output of that, and then you want to sort it in file size maybe. Or similarly, you can use your grep and whatever commands that you're using within the grep. So you can check, is the file starting with D? To check if you have directories. And then maybe you're going to get that output to become the input of line count. So you're actually going to find out how many directories lie in your wherever you are, your working directory. Pipe isn't the same as redirection. So your redirection, your greater than sign, will redirect the output of a file, the output of a command into a file name. Okay, so to your standard output, which is your screen, or else your input, You could redirect your standard input using your redirection, your less than sign, remembering that this, just using one less than sign, will overwrite whatever was existing in the file. Whereas if you use the double less than signs, it will append it to the end. So your pipe, if we do an example of sorting, here's pipe and sort. So sorting a file on the basis of the first three fields, right? So in here, if you went through some examples, this won't look overly super scary. So I'm saying anyway. So in here, the sort command, your minus t, what was that for? Of course, use your man space sort, and it'll bring you in, but I have them here. So your t tells us that the delimiter in this file, so whatever my employee.txt file, the fields are separated by a comma. By default, it's a space, isn't it, or a tab, which is seen as the same thing. So if you have something other than a space separating your fields, well, then you need to tell sort. Okay, tell your command. So there's your minus t, changes it, your delimiter, telling it what it is. And then you've got the minus k, specify the keys on the basis of which the sorting can be done. The format of it is minus k m space n. So in other words, you're telling it, as you can see up here, you want to sort on the basis of the first three fields. Sorted based on field 1, 2 and 3. Okay? If you wanted to ignore the case, which is often the way that you might want to use if you're sorting contents and data, the minus f will ignore the case. So allowing it to be case sensitive, because what if someone put in their name as all lowercase, or what if they put it as uppercase? Do you need to go telling them, oh no, you're only allowed to enter your name in uppercase or lowercase? In that situation, you can just get your commands to ignore the case, should that not matter for these. Minus n, sorted numerically. Maybe it's by staff ID, maybe it's by a start date when they started working, maybe it's by car reg, whatever your records are. And then minus C would sort and remove duplications. If it sees it, you've accidentally, or somebody has put in the same record a second time, you can use a minus C in there. What about if we wanted to use grep, whatever grep is going to be used for? Okay, let's have a look at an example there. You want to return only the lines that do not contain the characters MANAGER. Right, the result should be in reverse order. Okay, so now the pipe is going to send the output of one command into the other. The filter is going to take the input from one command, does some processing, and the output. You have your output then. So you have your cat employee, that'll just list out the employee text, and you are going to filter it. So the output of cat employee, in other words, the output of the full file, reading the file, that's what cat, concatenate, becomes the input of grep. So the grep can be used to find strings and values in a text document, such as that employee.txt. So you're saying search for the word manager, so grep manager, but we've added in a few extra little optional options here. So in here, we've got our minus v and we've got our minus I. Remember what those ones are for? What is the minus I? What is the minus E? V? From that then, I want the results to be in the reverse order. So anything that doesn't contain manager, it's going to sort them in reverse, your minus R, which shouldn't have a space there. So in there, your sort minus R. Okay, make some sense of that. Do it, open up your command line, type in that and see what's happening. What is your output going to be from looking at your employee.txt file? Counting files. We've used this pipe from almost day one, because sometimes if you run a command and it starts whizzing down the screen because the output is so long, well then you can make it scrollable. A very simple way to do that is just piping it into a command called less. All right, so that would be less. It'll make it more easy to read. But what if you want to be specific about what numbers that you want printed out? So in here, You have your ls. That's going to list all of the files. But you actually only want to see the first 3 lines, right? So line 1, 2, and 3. But you want to output only the 3rd one. So it'll print output the last. So there's my head minus 3. That's going to just print the first 3 lines, and then this will print the last line of that command head minus 3. In other words, you only want to print the 3rd line of the ls command. There it is. Okay. What if you want to store that for use later for whatever reason? You can, of course, combine your pipes with your redirection, as I said already. So you can get that to output to a file called my output. Okay, but if that my output already exists, you need to be careful, because as it stands there on my notes, the single greater than sign is going to just overwrite any content that was in that file already. If you wanted to append, well then of course use 2 of them, 2 greater than signs, so you can append it to an already existing file called my output. Because remember, poof, and it's gone. If it gets overwritten, it is pretty much impossible to get it back again. You don't have the backup of a recycle bin. Counting your lines, how many lines are in that? So you can have word count minus L, so it'll do the line count of it. What if you want to do more than that? How many files? You want to do a line count of the number of files that are in your home directory. So ls, just what's in your tilde in your home directory, and pipe that into your word count for lines. Right? Do it. How does it work? It should return just a number. So pipe this to less to inspect. If you decide that on your home there was a load of files, there was 100 files, and now you're quizzing, trying to scroll back up to see, well, what were the first ones that were there? Instead of that, you just pipe it into your less. And how many lines are in the /etc? What is the command for that? So in summary, that's for you. In summary, your pipes, your syntax is a vertical line. You can pipe from one command, the output of one command, such as the history. What commands have you been using? And you can pipe that into less to make it scrollable. What if you only want to see the first 5 lines of your history file? Well, then you can run your history, but instead of sending the output to the standard output, you instead send the output into the command head minus 5. So show me the first 5 lines of my history. And counting the number of lines in your home directory, in whatever directory it might be. ls, location if you want. Otherwise, if you omit that tilde, it will just list the files of wherever you are currently at the moment. And then your word count minus L for the line number. Okay, all hopefully fairly self-explanatory there. And we shall move along to week 3, today's new content. New but familiar, I'm hoping, because conditional statements, your for loop, your if statement, your while, and so on. They are your specific statements that allow us to check if a condition is true or false and to execute certain parts of code depending on whether the statement is true or false. Okay, so you have those examples, your if statement, your if then else statements. The syntax of them might be slightly different, but if you've got your head around the concept of them, everything being binary, it either is or it isn't, no grey areas, well then, that's half the battle. Right, this test is just simply a test to know is something true or false. So the test command, that's all it does. Test if something is true or false. So whether 10 is greater than GT, greater than 55. Test doesn't provide an output, but instead it returns the exit status. Remember that? Yes, of course you do. So your exit status then of 0 is true and 1 for false. Of course, that doesn't make much sense to an end user if they see is 10 greater than 55 and they get a result of 1. Is that an error? No, it's not. It is the expectation that the test command will return the exit status. Remember, 0 is that the command was successful. In other words, that was true. Okay, so there's my echoing dollar question mark. Echo back my exit status. 1, why is 1 there? It's because it is a false, or the test has failed. 10 is not greater than 55, so it's a false. The test has failed. That is back to your exit status from last week. So your echo dollar question mark returns the exit status of the last command. So that one was a false. So when the test fails or succeeds, of course, instead of that number 1, which an end user is looking at going, the hell is that about? You can, of course, make it a bit more user-friendly, be nice to the end users and let them know exactly what's happening in your file. So there you can do a test. So the test is 56 greater than 55? And there's my and. So run the first command, and then remember that we had those last week as well. Your double ampersand means run this one if it's a true statement, and run, or there you have an or, your double vertical lines. So test is 56 greater than 55. Yes, it is, isn't it? So we would expect it would echo the true. There we go, it echoes true. Wonderful. What about the next one? Is 6 greater than 55? No, it's not. So I'm expecting if the first command executes as a true statement, that's where your ands come into it. Otherwise, that's where your or's come into it. It will echo a false. And there's my false, as I was expecting. This can be rewritten. The purpose of it, rewriting it using square commands down here, is because this is how an if statement works, isn't it? Yes, of course it is, because you've done if statements already in your programming module. Okay, so in here, instead of writing the word test, it's implied that it is a test once you put it into the square brackets. So rewriting that, streamlining it, making it look so beautiful. You're combining the ands and ors, and in this case, you're replacing the word test with your square bracket. So test this, 56 greater than 55. If that is a true, if the exit status of that command is true, well then echo true, otherwise echo false. Of course, that echo can be whatever you want it to be. This is just your basics. So in the terms of this test command, the purpose of it really, you would very rarely just do it expecting a true or false answer, but instead you would use it as the test part of an if statement, okay? And that's where the syntax, the format, the look of it comes from the test statement. Your arithmetic operators, I've left some of them blanks because you can pretty much guess. I know how highly intelligent you all are. I've heard all about you. You're equal to, greater than equal to, greater than, less than or equal to, less than, and not equal. Okay, that's what all of those are. If your bash double parentheses are not used, the test command must be used to compare them. Okay, so in there, following on from that, I have some examples. I'm bringing you in there to your conditions section in your if statement. So here it gives some example of what you might use them for. So there, if you're testing, you can see these are more real world example than just testing if 6 is greater than 5. If you want to check if a file sample.txt exists in your home directory, making use of your -f file name instead of the -d. So in here you want to test, does this sample.txt exist in your home directory? If it does, print file exists. If it doesn't, well then maybe create it. Users don't want to know it doesn't exist. What you want to do now, I have to create it, don't I? Get the system to do that. So there's a nice real world example. If a file doesn't exist, well then create it. So there's your touch. Remember, touch just allows the file sample.txt to be created without editing it. Whereas when you go into nano sample.txt, it would open the nano editor. So the touch just creates the file. That's where our file doesn't already exist. Okay, the test command is used as the test part of your if statement. So your if statements then, again, of course, as you know, they check if a condition is true and if it'll execute certain parts of code if it is. So a true or a false statement. Your equals does a string comparison. Your dash EQ does numerical. Okay, so if test, now there's your command you just did a minute ago, then whatever, what do you want to do? Do you want to echo back something? Do you want it to perform arithmetic calculations? Do you want it to run whatever commands you have or whatever you've stored in the background? Do you want it to exit? Do you want it to open up another file? Do you want to use pipes, loops, whatever you want, as you would expect? So your if statement allows us to make our decisions in our bash script. So running a piece of code or not, based on whatever your conditions, whatever your test is. Okay, so looking at this, if a user's input, so if you've, assuming that you have asked a user, you've used the read command, reading a user's input, if the user's input is not equal to whatever their password was meant to be, then whoops, wrong password entered, and you can exit. There's your exit status, and there's FI to finish. So you can see it's just if spelled backwards, isn't it? So your if statement, closing your if statement, is FI, if you want to say it as a word. So it's just FI, your if statement, backwards. In there, don't forget the conventions of it. The square brackets on the if statement are a reference to your test command. So it means that all the operators that test allows can be used here. Again, go into man test and see what operators are allowed. In here, an example, how to use exit codes if in a script with an if. So you want to return a message if the user has the file, right, runs the file. So if the file employee.txt ran successfully. So there's your bin bash. Catch your employee. If your $? Your exit status is 0, the file, whatever file name is, ran okay. And the exit of 0, remember that's the success, isn't it? Otherwise, oopsie daisies, your file has failed, so you can exit. So your exit code of 0 is success. Otherwise, it's anything else, generally a 1 if it's a failure. If then else, we're adding in, if you have extra commands, sometimes you have a series of conditions that you want to use, such as here, if you want to check if a file exists, right? Because what you might do, a more efficient way of doing this is just what I mentioned there a minute ago, that you could use a touch command. If a file doesn't exist, but you need that file, well then you can get it to create that file. So you could have if -f employee.bak, which stands for a backup file, if you had a backup file. It's a regular file, so that's just testing the file type. Otherwise, the file isn't found, right? How to use your exit codes within that, remembering that your exit code of 0 means a success. So if your previous command has run successfully, there should be an exit code of 0, all right? So if your exit code is 0, then you do whatever you want to do, because the last command was executed successfully. Otherwise, so maybe, yeah, the file exists. Otherwise, the file didn't exist, so now I'm going to use my touch command to create the file. There's your FI to close your if statement, and then I've decided that I'm going to exit from the file, from the loop. If, then, elif. So again, there's your if, then, else statement. So there's your count. If it's equal to 42, that's correct. If it's greater than, it's too much, or else you need more. Okay, very basics there, but just to show you the syntax. And again, the square brackets coming from the test command. Okay, so that's your if statement. In your shell, you've got a special variable called $hash. Okay, and what that does is it outputs, it counts the number of parameters, the positional parameters. Remember that? Yes, of course do, from last week. So your $hash will output the number of positional parameters. So if you ask a user to enter their first name, followed by their last name, followed by their email address, you're expecting an input of 3 different positions, 3 different parameters into it. So you can check it. So in there, or else what if they entered nothing? Are you going to allow them to continue on through and have store blank fields. So if it is equal to 1, then you can echo back whatever you want. Or else invalid arguments, please pass only one argument. So that is in particular that if it's equal to 1. Maybe you want to check if it's equal to 0. Oh, you need to enter some value and run it again. You decide on that. So again, go into the labs. I have a section back in that conditionals on your labs. There is some if statements there. Make a backup of employee.txt called employee.bak, just that you don't mess it up. Write a script RMOLD which checks if an old temporary file exists called employee.back, and if so, then delete it. So you're creating a backup one, and then you're going to create a script to delete that. So again, check if the file name exists. So if your file name exists, then you can remove it, right? If it's a regular file, you can use your -f. So again, you can give it a more improved version of a standard output for the command line for the user to see, right? Give a go at them, because again, if you practice them, that's where you realize, oh, whoops, God, that's annoying that there's, a space here or not a space there, or I forgot to, whatever it might be. Practice. That's all I can recommend, because when you're looking at, or if you're following along on this, visually looking at them can be a different story to actually practicing them. Loops. So you've got your conditions, your if statement. Now you've got your loops. You want something to continue on, the fundamental concept of any programming language. You want to run a series of commands over and over again until some specific condition, whatever that condition is met. So you want to check for a condition and run certain parts of code based on whether that condition is true or false. What's the most common one? Of course, your for loop. So again, allowing us to check a condition and execute a certain part of code for whatever that is when the condition is true and also false. So loads of resources. A great resource in general, it could be for HTML, it could be for Bash shell scripting, it could be anything, is this W3 Schools. In here, look at there's great help files in there, right? Help sections that you can go through in there. So W3 Schools. And again, it is a link if you have downloaded that file, so you'll see it links directly into it. For loops, that's where we're at. Of course, here is the syntax of it. Your general format: for a variable in a variable list, do some commands, and then we're done. So loops in any programming language are used to execute whatever series of commands you want or tasks that you have to do over and over again until the condition is false. So it is important when you're specifying a range like this that there isn't spaces. If you're using in here, looking for a number, if you've only got a short number, that's grand, but generally you will be putting in ranges of, it could be A to Z, it could be 0 to 9, because maybe you're checking, has a phone number been entered? Are they just numbers? Is it numerical value? Okay, so you can see your for loop there. Oops, sorry, I zoomed on a bit quickly there. In this case, prints numbers from 101 to 105. So for the numbers 1, 2, 3, 4, and 5, have a look. There's your EXPR. And again, that is a little outdated at this stage, so that could be replaced with your double parenthesis, isn't that it? Your double opening brackets above number 9. When you're using a range, you can use the curly brackets. For a value in from 1 to 5, for a value 10 to 100, you can use the curly brackets. You don't put any spaces at the curly brackets. If there are, it won't be seen as a range, but instead it'll be seen as a list of items. So the first value could be 5 to 1. It just means it will count backwards, won't it? And then you can echo out the value and echo back all done when it is done. So I want you again to go back in, having a look there. It says look through the code. What's the expected output? And if you run it, then does it work? You can see there's a break here. I'm going to come to that. I'll explain that in a few minutes, what that does. So you have, in this case, a nested for loop, don't you? So look at your nesting. There's a nested for loop, and inside that, there is an if statement. and you've got all of the syntax of it there. So again, if you were to just copy it down, look at it and just write it down, rewrite it out in your terminal command, it is just familiarity with curly brackets, square bracket, normal brackets, all of those things to get to grips with. For loops then, another very common one is of course your while loop. While something is true, output some commands or some tasks, complete those. So the general syntax, while and in your square brackets. So after the while keyword, the condition is given in brackets there in your square brackets. If the condition evaluates as true, it will execute the do command. So you can do whatever you want. And of course, your while loops, you increment or decrement. Recall your use of double parentheses where you can increment and decrement within your double brackets. The execution moves back to the condition, keeps on executing as you would expect it to be until whatever condition this is becomes false, and then it jumps out to your done part. Okay, so in here, I have a file that you can practice with. It's up on the lab page. Where is it? It is called distros.back, and it is just a sample file on whatever page. Where are we? Into loops. You see, where did I give you a link to it? Maybe it's not coming up yet. So there is a file called distros. There we go. So it's in under the said part actually. So this is just a sample text file. Okay, you can download it. I'll just show it to you because there's nothing too extravagant in it. All it is just a sample file that allows you to play around. Okay, so a history of the 3 popular Linux distributions released many moons ago. Okay, so there's some dates. So the name of the distribution, the version number, and the date of release in that particular format. So in that case, it'll be just easy for you to work down through any files if you want. So in here, the example that I have here, this while loop, your program language, there's your general while loop, there's your syntax for it, and scripts printing out the numbers from 1 to 10. So there's your variable, when it's less than or equal to 100, echo it, and there is your increment, which you can now, and you should, streamline it into using the square bracket. So if you use your, or you're not your square bracket, your double parenthesis in there to increment it instead. If you want to file, there's an example. If you have your file, you can see what's happening in the next one. One of the most common uses of your while loop is to read a file. So reading a file, reading a data stream, reading a variable line by line. So instead of controlling the while loop with a condition, you're using the input as a redirection. So it's input redirection here. So you can pass a file to the read command, which controls the loop. There's your read command. So you can read your file is equal to whatever your file name is, employee.txt. So while read minus R line, echo back the lines. And you can see you're taking the input from the variable file, which is the file name here, employee dot whatever it might be. But it just means when you set it to being a variable, it means if you want it to come from a different file name, you don't need to go down and check your anywhere that you've used the hard-coded file name, but instead you can just change the variable up on the very top and say, well, instead of it being employees.txt, it's now distros.txt, so it's an easier way there. The minus R option there, the read minus R, prevents the backslash acting as an escape character. So we have the backslash likes of dates. If somebody put it in using a backslash instead of your forward slash, it's not going to come up with errors in there. So that is just showing an example there of where you are reading your file in. So it is a very common way of using while loops, is reading a file taking your data line by line from a particular file. Okay, so you're using your read command there then to take in each of those lines and use them as part of your while loop. Infinite loops, yikes, who wants to get lost in an infinite loop? I'll remind you as well that Control C is if you're testing loops and you realize, whoa, see, I'm after getting into an infinite loop and I can't get out of it, it's running. Control C will allow you to cancel that. Okay, so in your infinite loops, one of the good or the bad things with while loops, the advantage of running the loop for infinite period of times until a condition matches. The biggest drawback is the exact same thing, that it's an infinite loop until a condition matches. What if you don't hit that condition matching? Then it's just eating up resources and you're gone into an infinite loop where you're not too sure what you're doing anymore. We will come to break and continue statements later, and you will be using those with infinite loops with while something is true. So in this, while true indicates the while loop will forever iterate. If it returns quickly, its benefit is that it inserts a small pause between executions. So while true, so you're saying that while this is all running okay, it'll run forever. So adding in a sleep command will allow you also that you can have a gentle pause in your file as well. So while true, echo, I'll continue to iterate until you press Control C. Let me also rest 1 second between every iteration. There's a sleep of 1 and do. It'll keep going. Do, echo that, sleep 1. Do, echo and sleep 1. Do, echo and sleep 1. Okay, so that will loop and loop until you press Control and C, which of course we're not expecting the user to need to press Control and C. That would be a system flaw, wouldn't it? So I will come to, and I mentioned the break and continue on that. Your $hash shell variable outputs your positional parameters, as you know. So if the positional parameters are not equal to 1, then you can say, please only use 1 argument. So if it is 0 or if it is 2, then you're going to tell it, please enter your first name only. Okay, something like that. And then there's your exit 1. So your exit 1 will indicate that a file has exited with an error in it because there wasn't an argument for the file name. So here's just an example. While it's not equal to 1, do whatever you want to do. So that is checking the number of positional parameters, the number of arguments that have been entered at the command line. What you can use is another conditional checking. So in this case, you have an until. Until a condition. This is very similar to your while loop, except that it's pretty much the opposite way around. So while the until loop executes given set commands as long as the condition evaluates as false, whereas your while loop is the positive, optimistic one, saying that while the condition is true, execute all of those. So why bother having the 2 of them? Well, do you know what? You'll probably never use a while or an until that you can do everything with a while loop. It is just that maybe you don't necessarily need both, but the while loop would be able to handle every scenario, but depending on what you're trying to achieve. So the condition is evaluated before executing the command. So if it evaluates as false, the command is executed. So it's pretty much an opposite of. So the return status is the status of the last command executed in the consequent commands list, right? Your condition can again be any command that can exit with a success or with a failure. So maybe you have, is my counter greater or equal to 74? Okay, so very similar. It's just that it does it the opposite way around. So again, I will bring you back into your labs there and ask you to jump out onto the lab section where you've got your while loop. So while your number of arguments passed is not equal to 5, do something. You must pass exactly 5 arguments and exit 1 because that wasn't successfully run. Okay, they entered the wrong number of arguments or whatever it might be. Okay, so that is a bunch of loops, isn't it? So in there, that is the first section, your conditions and your loops. And I'm going to move along then. So what we'll do, I'll just change my screens now for the second part is loop manipulation. I have mentioned just in passing about your break and your continue. So what I'll do now is I'll go down through those. You have your case and escape and all the rest. So let's just get started on that. So these are all, they would be considered more advanced features. It's about you being able to manipulate files, manipulate text inside them, using your while loops, your for loops. Of course, programming doesn't really exist without their use because you need to be able to manipulate your text in some way to have it something going on with it. So the first one that I know I've mentioned there is this break continue. What's all that about? So the break and continue statements in Linux manipulate the flow of your loops, as you would expect. So to begin with, your break terminates. It terminates the control loop. Oops. It terminates your control loop. I'll just turn on my little laser so I was trying to do, and it'll jump out of it. So it passes the program control then to the command that follows it. So it jumps out here and hits here. Hits outside the loop. So let's go through some examples. If you want to exit a loop early before it naturally finishes, you can use a break statement. So you're saying leave the loop straight away. So it terminates the control loop and it passes your control to the command outside of the loop, whatever is the next command to be executed. It may be because of a normal situation that could cause the loop to end, but there's also exceptional situations where it should end. So maybe you're copying files, but that's grand if there's all enough disk space. But what if it reaches a critical storage space amount? Then maybe you should stop copying those files. Or what if the file is extra large, or if the file is a particular file size? There will always be situations where you may need to use your break statement. So in here is an example then of break in here. So while I is 0, so while I is less than 5, echo the number. So if we start with 0, it's less than 5, that's true, so we'll echo 0. We'll bring it up to 1. If it's equal to 2, then break. No, it's not. We're only at 0. So I'll stay around my while loop. We have iterated to 1. So 1 is less than 5, great. Print out 1 and check, is it equal to 2? No, it's not. Well, then I can continue on. Now it's 2. It's after iterating from 1 to 2. Print out number is equal, so echo the number and your iteration. If it is 2, then you break. So once you hit that, you are going to break out of it. So if it's 2, then you break, it jumps out and it echoes back. All done. Okay. There is an N, a usage of an N optional argument in there because you might have nested loops. So you might need to break 2 loops. You might need to break 5 loops. By default, it'll just break 1 loop, won't it? So in here, what you might have, in here, it's just breaking out of however many. So if you knew you had 3 loops, for loops, while loops, you can break out of them. So you might have a for loop and a for loop and an if statement. You may need to jump out 3 different levels. And again, that brings the importance of adding spaces when you're doing your programming, of having good syntax, which you've all used as well, where you indent a little bit, as you can see on the examples that I use as well. So your continue statement, so the use of break and continue are the same. The difference is how they behave when they're executed. The continue exits the current iteration of a loop. So it skips the remaining command and it passes the program control to the next iteration of the loop. So your break jumps out of the loop, your continue jumps out of this iteration. So you might be using a loop to process a series of files, but you stumble upon a file that doesn't have read permission, so you can't process it. You still want to continue on down through the rest of the files. So you're just skipping an iteration, okay? So there is your while I is less than 5. Increment it. If it's equal to 2, then what are we going to do? Skipping 2 and moving on, and it'll continue on. So the output for that, what would be expected, it will have I is equal to 0. It iterates it, brings it up to 1 before it ever. So it checks, is 1 equal to 2? No, it's not. Continues on, echo 1. Goes back around. 1 is I less than 5, yeah. 1 becomes 2, 2 is equal to 2. Skipping 2 and moving on. And there we jump around again. Up we go. 3. So there's my increment. I'm getting tongue-tied here. And you can see the output of it. So skipping number 2, moving on. You have number 3, you have number 4. There's an accidental hash symbol in there, so I'll remove that. And you move on from there. Okay, so you can see break and continue are very similar, only in the fact of how much that they come out of. So your continue just leaves one iteration, whereas your break exits the loop. Okay, so that was just that, getting rid of that hash symbol. The next up then, we have the case statement, okay? For menu-driven scripts, this is, it can be difficult to accept user input and validate it. So you have to account for every possible input. An easy way around this is to create a multiple choice menu for your bash scripts that define a predetermined set of options that a user can choose from. So you know, often if you're filling up forms online and you see a county drop down and it has all of the counties pre-populated for you. So you're not going to make any mistakes because there's many counties in it. You're not going to have errors with that. So menus are often a case in your bash shell scripting where you can predetermine what the input will be, and then you can use a case statements then for that. So your case, just like with your if, and when you're at the end of the if, it becomes fi. Your case, and at the end of your case statement, spell it backwards, ESAC. See that? So in there, it executes different blocks of code depending on the value of a variable or of an expression that you have. So they're specific statements. They allow us to check a condition and execute certain parts of codes then depending on what the user has chosen from. So an example in here. These are best used as an alternative to nested if statements. So you could say, if the county is equal to Kilkenny, then do something else if it's equal to Tipperary, else if it's equal to Cork, else if, and you can see it ends up going on, and it becomes very tedious as a programmer. Whereas this way, you get a nice menu-driven script. So the nested if statements might be familiar to you, but as soon as you're confronted with a few different scenarios, different actions to take, they can just get so confusing. So this one is a much cleaner, much more efficient way to run different code based on whatever variable, whatever expression that the user has chosen. It's not a loop. There is no loop. It doesn't execute a block of code for 5 times, whatever it might be. But instead, it just, as I'll just give you an example here, what it does is it takes an input from the user, Kilkenny, and if it says the case, if it's the variable value is Kilkenny, then it will whatever. Okay, so it takes in a word. If the variable word is add, it will do my add. If that variable word is removed, then it will do whatever my next set of commands are. If my variable that the users put in quit, then it will quit out, exit, thank you for working with my system, hope you liked it, and gone. And there's my asterisk, my default for anything else. And there's my ESAC, case, spelled backwards. So what you can have, you always quote the variable. So case, quote, variable, right? So there's my case, quote mark, dollar, and my variable name is just called word because that's what I'm after taking in from the user. In, and then these are the options. So do I want a menu that says add, remove, quit? They're my options I'm giving to the user, okay? The pattern can be exactly one. You could just have, okay, if it's add, then I'll do this, otherwise we're finished. Or it could be, has the user inputted lowercase, uppercase, YES, uppercase, YES? And for any of those, it just takes a catch-all scenario. Or else the anything else, your wild card, so your dollar. So you're saying if they have the dollar sign there. So in terms of that, the case and escape, the overall syntax of it. That's what it looks like. So you're reading in a user selection. The case statement then starts. If the user selection is choice 1, it'll perform some actions, or choice 2. But look at the syntax. You're reading in a user input. That's the whole purpose of this, is that you want the user to input or to choose from a menu, I should say. Whatever they have chosen then, the choices add, remove, so add a new record, remove an old record, whatever it is, the actions, and you can see there's a double semicolon at the end. There's the next choice with a single closing bracket, whatever your commands are, and a double semicolon. And once you're finished, you get that case spelled backwards. So here's a full example. Choose a contact to display information from. So echo, there I'm echoing back all of those. I read the person. What has the user entered? C, J, S, or R? If they've entered C, uppercase, or lowercase, you can see there you have an R symbol. It's not a pipe in this case. You should be familiar with, if it was a pipe, it would be commands, wouldn't it? So if they have entered lowercase or uppercase C, it will echo back Chris Ramsey and their email address. Whereas, there's their postal address. If they've entered J, uppercase or lowercase, you'll echo back his name, email, and address. If they've entered S, you get it. Down to the end, and you can see for every case, for every option that the user has, the double semicolons don't occur until just before the next case statement, all right? So there you get all of those. So there's your double quotes there at the end. So again, I have in here an example of a case statement. So, so for your menu-driven scripts, you might just have simple yeses and nos, but you might want to offer the user the option to enter Y or N, or YES, or NO, or capital Y and capital N. So again, you can use the catch-all scenario for those. Try that out. That's a good example. Very simple, but yet it gives you the syntax, the format of it, and the options that you need to have in it. So there you go. An example on that, right? From case, we're moving on to what's called a select statement. It is this time when you've got a larger menu. So you can see even already with, if I go back a page or two, this one, choose a contact to display C, J, S, R. What if you had 10 or 20 of them? It can become very confusing. Instead, what you might like is to have a numbered menu. So you can say enter 1 if you want to see details of, 2 if you want to see. So look at the little screenshot that's there. Just showing you what you want to do. So do you want to, are you a student, business, professional, fresher, enter your choice. You're still studying, enter your choice, whatever you want until you're finished. So you can have the same, the users are allowed to choose an option from your numbered menu in this case. You can give the menu options. You can create a simple menu system. So using this, I could have a variable called options. My only 3 options are add, search, and quit. PS3, we haven't come across this, not a PlayStation, no. In here, your PS3 allows you to change the command prompt, because otherwise you end up with, as you know yourselves, hang on, where's my matrix? You have this Caroline dash VirtualBox : tilde and a $sign. if I changed my PS3 is equal to choose one option. If I use a change like that, oh well, I suppose I have to put it into a thing, variable. If I had that in the script, what it allows me is it will change the variable, my PS3 variable. So it allows my prompt to change from it being all of that Carolyn at Carolyn virtual dash virtual box and the rest of it. So if I were to look at what my PS3 looks like, if I just echo back the contents of it, now it says choose one option. All right, so that is just looking. So I have changed that. There's my command prompt. If we were to come back out, that it will have your PS3 for the purpose of running your script. So choose one option. Select name in option. So name is my new variable. Selecting my variable name in the input from options. So if the user has input, if it's equivalent to, I'm saying equivalent because it's comparing strings, isn't it? It's not a number. So you're doing a string comparison now, you're double equal sign. If it's quit, then you echo out and you break, and that's it. We jump out for our loop. We're done. Otherwise, there's my else if. If the variable name is equal to whatever, blanks, then it's an invalid option. Otherwise, you've selected add, and maybe I could do a /add.sh, and it'll bring me off running another file, another script, and run through the commands, whatever commands I might have in a script called add.sh. I might have another script called search.sh. So those could have full commands for, and all of the script, all of the language that allow me to add a new user, a new record, or to search all of my records. Again, you're using whatever you want. So you're using creating a simple menu. Gives the user a list of options, a numbered list of options, and it prompts the user for an input. So the select loops until break is called. So it'll keep on looping until quit is called, and then it jumps out and sends my control to the next commands outside of the loop. A few points when you're using your select, there isn't any error checking, so you have to do that. Are the users putting in the correct format? Are they picking the correct numbers? If they put in 17, what does that come up with? So if they put in anything else, remember our asterisk there as well. If the user hits enter without entering data, what happens? Do I allow the user to go back in and try again? The loop will end when the break statement is issued. So what you have in summary of all of those, you've got your while loop, you've got your until loop, you have your for loop using break continue, and then you've got your select and your case statements. All have their own purpose, all have their own positions in it. So one of the easiest is your while loop. While an expression is true, keep executing the codes of line. Your until loop is similar to the while, the difference that it'll execute commands within it until the test, or while the test is false, isn't it? Until the test becomes true. The for loop, a little bit different to the previous two, your while and until. What it does is say for each of the items in a list, you perform your commands, and most of the time your loops are in an orderly manner, but if you're intervening, if you alter it, you should be using either the break or the continue. Your break tells Bash to leave the loop straight away. So it could be a normal situation, as we said. So it could be just copying your files, you don't have more space. Whereas continue tells Bash to stop running through just this iteration. So just one little hiccup will continue on down. So you might have circumstances that stop us from, or need us to skip one iteration of a loop. So maybe you're using it to process a series of files and then you don't have execute permissions or whatever it might be. Your select then allows you to create your simple menu system, your numbered menu system, and that's very similar to your case. When you're testing your loops, don't forget to, if you need to interrupt, if you need to kill a current process, you can use your Control C. So using your Control C on the keyboard will allow you to return back to your prompt when you're testing out loops in particular. You can get caught in an infinite loop. So Control and C will allow you to get out of a loop at any stage. For an end user, if you're creating a system, they shouldn't have to Control C out of something. You should be checking to make sure that if the iteration is gone into an infinite loop, that you're catching it, that you're breaking out of it, and that you exit correctly and as expected. So a user shouldn't have to use a Control C on a system. That's fine for you, just testing loops and things. So try out the labs. We have menu-driven scripts. You can see there's some options there to add, search and quit, and all of the options that you might have there in terms of using a select statement, and then within that you have a case statement, all right, and all of the syntax that belongs to it. All right, so that is a nice little starting point there to get you up and running on all of your different constructs, your break, your continue, your case statement, and your select statement. And the last part, as you can see there on the screen, is using said. So we'll come to that next. Into the third and last section for today is using said. I'll just see there when I'm looking at my screen, I can see my wheelchair headrest behind me. You might think I'm lived in the lap of luxury on a fancy recliner chair or something. Right, in here, we're on to said. This is a hugely important part of being able to manipulate text and files, because what it allows you to do is to transform text on an input stream, whatever that input stream is, whether it's from your standard input, whether it's from a file, or whether it's from an input to from a pipeline. So as you can see there, for finding, replacing, deleting, and inserting text. So it works line by line in a file, which makes it hugely beneficial for us as you're editing. Said, what it stands for is a stream editor. That's where the S and the ED comes from. So it is a very efficient way to perform basic text transformations from your file, run down through a file, or from taking an input from a pipe. So it's in its ability to filter text in a pipe is where it distinguishes it from other editors, right? So one of the most popular functional parts of it is being able to use a search and replace using from one string to another. So you can make global changes to a large file. What do you mean by that? I can change, let's say, for example, if I had a file and it had 2024 written all over it, I can run one said command that will allow me to change every instance of 2024 to 2025. And it could make 180 changes, all right? So it can make global changes to a large file. As I said, it's a search and replace functionality is what makes it most beneficial. So it allows a script to make changes to a file. So I can store said as part of a script and I can run it. So I can call my script 24 to 25 and I can run it then, and it'll, if I have my correct contents inside it, my correct commands, it will make changes to whatever file. So I can take an input file into it. So of course it requires an input file and your command to let said know what's it meant to be doing in the first place. So it uses text substitution. You can print specifics in a text. So at the minute, if you're printing out, by printing out, I mean printing it to the standard output, printing it to the screen, showing the user what are all the names. Okay, so you can have selective printing of files. You can replace text in place. What that means is if I have a file called apply.txt and I replace all 2024s with 2025, what if there was I'm assuming that it is year, but what if that was expenses of the employee, or what if it represented some other, maybe their ID or something like that. So you just be careful replacing text in place, in other words modifying the file straight up, because it's irreversible unless you have created an employee.bak, a backup file for it, before messing around it. And non-interactive editing of files. So look at, we'll go down through some examples of it anyway. So it can be used at the command line. If you're just doing basic once-offs, you can use on the command line. But obviously, having said as part of a script makes it more beneficial because you can reuse it. That's what scripts are for, making them reusable. Whereas when you do a command on the command line, it's just done once and that's it. So using your script then in the shell, you don't need to open your file. You don't need to edit your file through a text editor, trying to do a find where all of those 2024s are and making sure you're replacing all of them. It executes commands on a line, okay, so it works, it is line based. So when it sees, let's say 2024, it will move to the next line, unless you specify otherwise. So it'll just replace the first instance per line. So then it'll display the results on an output stream. What's the output stream? That's up to you. Is it the standard output, your screen, or is it to another file called 2025 staff listing? You decide. Your syntax then. I'm going to run through some of the different syntax for SED. And again, of course, there is, if I just open up my command here, yeah. This is where I'm asking you to use that distros file, which is just a blob, okay? It's a blob of content, as you can see there. So what you'll use with that distros file then is, for example, you want to print only lines 7 to 9. I'll show you how to do that. You want to search for a pattern and only print, let's say, the ones that match Susie. You want to negate, you want to find everything that's not Susie and print those. Practice, 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 because that's what makes it become familiar to you. All right, so there's some practice and there's some exercises. I will come back to them. So in here at the beginning, the syntax of it, if you haven't used it before, there's your command prompt. Sed is the command. And then your pattern. It's a regular expression, whatever it might be. It might just be the 2024, or it might be the name of something that is outdated. You don't use it anymore. So I might decide to replace expr with my command, which could be my double parenthesis. And there's my file. So your search and replace, that is the most basic format of it, is in a search and replace. There's your pattern and your command. In here, if I add in, so I have a few little, if I wanted, I can add an S to search and replace, a P to print, delete, D to delete, I to insert, A to append. I'm going to go through some of those now. The first one being a search and replace, which is the most common use of SED. So SED with my, it's not a quote, what's that? An apostrophe, a tick mark, whatever you want to call it. It's the straight ones anyway. There's my S, standing for search, substitute. Okay, I want to substitute cat, there's my pattern, cat, replace cat pattern with dog. That's my replacement. So as I run down through each and every line, the first instance of cat will get replaced with dog. Okay, so echo every line from, oh yeah, I forgot my file. I would have to have a file name in there as well. So in there, that would just, that's grand if I'm just running on my command line. But if I'm using a script, within a script, I need to tell it which file and making sure that that file is residing in the same working directory as where I am. Otherwise, you need to give it your proper full path name, don't you? So replace, echo every line from your my file, employee.txt, to your standard output, your screen, changing the first occurrence of the string cat on each line to dog. So typically used to replace a word, okay? So there's your cat for dog. And I have mentioned a few things there, changing the first occurrence, because if I had, the cat was here to concatenate, it would just replace the dog was here to concatenate. It doesn't see the cat on the second sentence unless we specify it. Okay, said is line oriented, so it just replaces the first instance of that search pattern unless we specify it. And the specified, if I wanted to do a global change, to change and be greedy and change every occurrence of the pattern CAT with DOG, I can add a G to the end of it. That means it's not going to be replacing the first occurrence anymore. It will continue. It'll do a full swipe through the entire file, not just replace the first, but replace all instances of CAT. Okay, so that's all instances and not just the first one. The -E option there, that in this case, it wouldn't actually be needed, because what the -E does is it allows you to run and embed multiple sed commands. So the -E means I'm going to run this command, this sed command, followed by the next sed command. Okay, so if you had more than one, you'd use your -E. So you can see it'll replace making the same edits on multiple files, which can be on different servers. Tedious, time consuming. That can all be done with a simple sed command. Maybe not simple when you look at it first, because you're thinking, wow, there's an awful lot there. But you know what? Again, if you go into practice, if you write these down and see, does it work? Do you have the right /? Do you have the correct tick mark, whatever that apostrophe is? Right, the next one, D, removing, deleting, D for delete. I want to search for pattern and delete it from my file. All right, what is this one? Look at this file here, or this command, sed caret, C-A-R-A-T, for any of you looking for dinner. So sed caret $, and D. What is that doing? Think about that. What does the caret stand for? It means the beginning of the file. So if we reach the beginning of the file and the end of the file and nothing in between, isn't it an empty line? So you can delete empty lines. Very common, popular use of sed, that if there was empty lines, remember it's line oriented, so if it's an empty line, it will delete it. Replace only on line 2. You can use the search and replace, but you can specify which line that you want to search and replace on. So I know that it's only in the first line or the second line, or from line 2 to whatever, and I can specify those as well. What about if you want to only print out your matching lines? Your N, -N, suppresses my normal output. By default, it'll print every line. So I'm saying search for the pattern, Kilkenny, and print only the lines from my employee.txt file. Okay, so print only matching lines. If I want to make it case insensitive, which it looks like a pipe symbol, it is not. It is a capital I, and that makes it case insensitive. Okay, so you're saying whatever the pattern is, Kilkenny, it doesn't matter if it's uppercase or lowercase, I want to print it. So there's my capital I, makes it case insensitive. All right. There's a bit in this, you're not going to remember it off heart, and I do not definitely expect you to, but what I want you to do is to practice them, okay? And the lab will help you do those. Your escape symbol, edit a shell script to refer, that refers to all of that to, and not to /bin. Look at this. Can all seem very confusing, but you know what? It's not, because you're doing the same thing. The -E is optional because you only have one sed command. So you're saying search for, there's my /. I need to escape my character. I need to escape my /, because the / is part of my sed syntax. If I go back to up here, my sed syntax is a / pattern, /. So these /s are special characters. And if I want to use anything, if I want to use those special characters and to read them literally, as opposed to implementing them as part of your sed command, my s /, that's lovely. But if I do a /bin /users /local, sorry, that's the wrong way around. I would need to escape those characters. I just reworded that there. So in this case, you want to replace the bin, right? We have our find and replace, if you want, inside in your what are we doing here? Your said, sorry. In here, you're replacing your bin with user bin local. So remember, you have your search pattern and then you have your replace pattern. So in here, as you see on this example, your said, and minus E is optional because you're only using one instance of said. So you're saying search for bin and replace it with user local bin. But look at all of these ups and downs with forward slashes and backslashes and all of the rest. So you want to search for bin, replace with user local bin, take it from your my script and then save it into new script or forward it, redirect it. So you're using redirection there. So new script will contain that. A much cleaner version of it. I confused myself almost. In here, I'm just, it looks so confusing. With all of these forward slashes and backslashes, the chances of human error is pretty high if you're like me. So instead of that, it is worth noting that any character can be used as your delimiter in your said S. Okay, so up to now we had your said S was with you have an S forward slash and then you use your search term forward slash your replace term and your forward slash at the end. But because you're already using forward slashes within the command, it gets very confusing. So what you can much more simply and streamlined do is you can replace. So look at here. Instead of using the said forward slash, so here's my forward slashes that actually belong to said if I just use a highlighter on them. Where's my lovely pen? I'll do it on green there. So there, oh, it's my pen. Sorry, I just wanted a highlighter. 2 seconds, not a pen. Highlighter is lovely. So there's my said forward slash. And then it searches for, I need to escape my character bin. And there is my forward slash in there that relates to, that's me, that's my search term. And here's my replace term. And here's my forward slash at the end. So what I can do, and you can see down here, is that we're replacing the S forward slash. My pen is so tiny. Why is that? Do I get an option on making it bigger? I don't know. Anyway, we'll work with it. So here, my pen. Right. So this S and a forward slash gets replaced instead with an S and a hash symbol. Similarly with my user bin, that forward slash gets replaced with my hash symbol. So instead of being the forward slash, we're replacing it with the hash symbol. So it doesn't actually mind what character that you're using, and it's in particular helpful when you're working with forward slashes already, that you just say, well, do you know what? I'm actually going to use a hash symbol as a delimiter or an @ symbol as a delimiter. So there's actually only 3 forward slashes that belong to the said command, but it's just because it's in the middle of all this mash up on top, it gets very confusing looking. Okay, so it just gets far too confusing, this top version, and instead a far more streamlined version would be if you have forward slashes as part of your command, well then change your delimiter for said into something different. As long as you're consistent, as long as you know the placement of them, it is cleaner and easier to read. All right, so that is a much nicer view. So that is still based on, where's my said, there's my said, there's my forward slash for input, forward slash output, forward slash at the end. It's the exact same thing, only that, whoa-zee, it became so confusing that I couldn't actually hardly decipher myself what I was trying to do because there's escape characters in it. And when you're escaping the forward slashes, there's bound to be an error coming in there somewhere. Okay, so what we do instead is we simply, and much cleaner, we just replace the forward slashes that belong to the said command with a hash symbol, or an @ symbol, or a pipe symbol, or a colon symbol, whatever that doesn't exist as part of the arguments that you're using. Just makes it far easier to look at. Your wildcards then, moving along to the next part, mean that if you want to use, like this one in here, you said, if you're replacing 0 to 9, so there you have your digits 0 to 9. That's my search term. So I'm searching for all single digits, and your exclamation mark or your asterisk is a repeat count. So it means that any number of digits that you have in there. So you are looking then, you want to take every line that starts with a number in your file and surround that number by brackets. Try it with your employee file. Maybe you want to do that with phone numbers. Maybe you want to do it with something, okay? So you can search and replace the 0 to 9 followed by any amount of numbers and replace them. You see your little @ symbol there. As I said, redirecting, the advantage of this is that you can redirect into files so that you can have them stored for later on. You can go back into them and say, oh yeah, that's my new up-to-date version. So by default it's written to your standard output, but of course, like any redirection, you've got that redirection arrows. So you're doing a search for the input, replacing it with output from my file, and you're storing it in a new file called new file. The -E is used to run multiple sed commands. It's optional when you're only running one sed command. And down here, the -I means that you are replacing all occurrences of input with output in that file. The -I, see, it's not redirecting, it means they will be replaced now. The word input will be replaced with output in that file, and your previous version of the file is gone. Be careful with it. I know I said up at the start that to be careful when you're replacing, when you're using inline. That's up there at the very start of it. I'll just come back down to where that said. Text substitution, selecting printing and replacing text in place. It's irreversible. So if you are replacing it in place, if the file is there, you just need to be careful with that. Okay, so the -I forces that. It allows you to edit the my file directly. Maybe you want to do that. You don't need the older version anymore. That is perfect. Examples to try out. You're now bringing in these special characters that we've used previously. Printing out only directories. In other words, they begin, how do you know what a directory is? It's because when you run an ls-l, the first character is a D. So look at that. There's your command to just print out if the first character of the ls-l command is a D. Okay, and you want to print those out to the standard output, which is just our screen. What if you want to delete lines that start with your hash symbol? Then again, your caret there, your little upside down V above number 6, use that. Okay. You can also use your $sign, meaning the end of file. So you want to delete all but the first 10 lines of the file. So there's your $sign using the end. There's your D for delete in there. Okay, so it's just being careful again of the use of those. You can use pattern ranges. So I could say, well, print out from Caroline down to Rosemary. So pattern range there, where the first regular expression, my name, defines the start of the range, and the second is the stop, your Roseanne. So the best thing to do, have you heard me say it before, is to go back into your labs, right? So having a look at this week's lab gives you good examples of how to use your sed editor. So printing particular lines, printing particular contents within it, searching and replacing in them. And at the end of the lab, once you're comfortable with using sed, you understand what it's all about, the main one of the main advantages of it being that you can use it for search and replace. And now once you're happy with that, moving on, I've given you an exercise. I'm slowly guiding you, gearing you towards the bigger assignment that's coming up as well. So Adding new records. You've got an employee.txt file, right? So hopefully you're all familiar with your own employee.txt files. I want you to be able to add new records into that. Of course, think about it logically. If I just open up my website so I can move it instead. Yeah, right, there's my set, there's my exercises, a few little, give them a trial run, and here's my adding new files, right? So when you are adding a new file, think about what you want to do. Take a step back and say, right, well, what do I need to do here? Does the file exist? Do you need to create it if it doesn't exist? Do you want the user to receive an error message? Do you want them to receive customized feedback, or just create it and let that be done? Do you want to give appropriate variable names? Please enter your first name. Please enter your last name. To the position and parameters, the first parameter being your employee ID and name and all of that. What next? Time to take the detail, and we want to append. You don't want to overwrite a file if it already exists. Is there error checking? Of course you have to have error checking in files, don't you? What if the user doesn't enter anything? Is that okay? Are there fields that are mandatory and some of them optional? You decide on that, it's your system. So when you're taking the user input, ensure it's in the expected format. There's a one now that you can have a think about. You will be needing that. How can you check if you're asking the user, please input your email address? How can you check that it has the correct email address format with your @ symbol and your dot whatever? Right? How can you check that? If you're asking for a phone number, does it have the correct digits? Does it have only digits? Are you using postcodes or air codes? Well then, do they have the correct format? Are they in the expected format? It's annoying when you're in a form, and I see this at times when you're filling up things, and it tells you, let's say the likes of the air codes in Ireland, it says it's not in the correct format, enter it again. And you're going, well, I'm not really sure. I don't know what format you're expecting it to be, because I put in my E12, E123. But then your system, maybe the programmer has decided, well, there should be a capital at the start or a small at the start. Does that matter? Do you need it to be case insensitive to make sure that as many options as possible are caught? Is there going to be a space or not? Well, if you're being particular about what the format of some input is, well then tell the user that. That would be nice. Please enter it in the format of, and tell them what you're expecting, okay? Is there brackets for the 086, or is it just 10 numbers, no spaces? Is it 3 for your prefix followed by your 7 numbers? You decide, but whatever your decision is, make sure that the user knows that it's not a secret mission, that they know what they're meant to be looking for. And there's some little bits and pieces. This will be, and you can reuse these bits of content for your bigger assessment anyway. So it would be a good idea to have a little look at those. There's some sample bits and pieces of code. You decide on what you would like to use. When you've entered the details, maybe do you want to confirm it? Are you going to put in some of those conditional loops and statements that we've done today? Maybe you want to ask the user what they want to do next. Okay, there's a bit in that. Okay, so taking your time. This is linked into your bigger assessment. And I have the final 2 chapters of your Cisco NetAcad. Oh, I hear you saying. So when you're looking at your NetAcad in here, right, there's all your opening ones, and we are down as far as chapters 10 and 11. You can see the available from Monday's class, right? I'm stopping at 11. After that, if you wish, if anyone wants me, or you want to look at any of these, I can open them, it's no problem. So there is understanding hardware, where data is stored, network configuration, system and user security, ownership and permissions. We've done all of that ourselves. And that brings us to the end of that Linux Essentials. If you want me to open any of those extra chapters, you want to eat it all up, that is fine, okay? I will open those for you, no problem. And that brings us to the end of today's class, right? So we've covered quite a bit in there. So you started with your labs. Oh, wrong one. So you started with the first number 3. Your conditions, your loops, your if statements, your for loops, your while loops. Then you moved on to manipulating those loops, being able to use break, being able to use continue, your little sleep if you wanted to use it, being able to create menu-driven scripts, being able to use case and select. And then we have the manipulation of the stream editor called sed, where it's used for find and replace, probably most popularly, but also can be used for printing particular outputs or for deleting empty lines. They're also useful uses of it as well. Okay, and of course you've got plenty to be chewing on in the labs for today as well. So that is that. Okay, I hope you're all doing well and managing as we reach week 3 of your notes. In class 2, I will be using AWK, AWK. I'm not even going to say any more about that because you can look forward to it in the next class. Right, well done. Keep up to speed and keep the communication lines open. Help each other out. Chat to you soon.